Jack Hidary, the CEO of SandboxAQ from the US. After spinning SandboxAQ out from Alphabet Google, he scaled up to a valuation of, and look at this number, $5.75 billion, backed by Nvidia, Google, and others. They have been recently named by Time magazine Top 100 Most Influential Companies, and it's really a nod to their role in shaping the future when it comes to AI and quantum and other technologies. He's going to be in conversation with someone who's been spending her career in really influencing and helping founders and ecosystem to navigate the edge of what is possible. So with great joy, I now introduce you to the Managing Director of MENA Startups at Genome. He is Samantha Evans and Jack Hidary. Welcome to the stage. Great to have you. Great to have you.
Thank you.
Hello, welcome.
Thank you.
Jack, you want to sit there? Hi, good afternoon, everybody. Nice to meet everyone here, and it's my absolute pleasure to sit here with Jack.
Great to be here, Sam.
Yeah, my name's Sam Evans. I am the Managing Director for Startup Genome. We're an innovation ecosystem advisory firm working with governments across the world to support them with their ecosystems. And we've seen AI and quantum be a very key area across the world. So it's a pleasure to sit here with Jack today. So, Jack, let me have you introduce yourself.
I think we're supposed to take off these badges, right?
You can take it off, yeah. I'll quickly do that. So SandboxAQ is one of the most important deep tech companies in the world. It came out of Alphabet. That was your previous?
Yes, we were in Alphabet first.
Yeah, and you are now valued at $6 billion. So Jack, please introduce yourself and SandboxAQ.
Well, Sam, it's great to be here with you. It's great to be here at North Star and GITEX. It's a very exciting time in AI and quantum. I think years ago, people would have been extremely incredulous if you told them that AI and quantum would be where it is now.
Right.
And we had a vision back at Alphabet to really take these two tools of AI and quantum and change the world. In biopharma, making new medicines for cancer, for Alzheimer's, for Parkinson's, in materials, in energy. Our vision is to take AI to the next stage, take us beyond language models into the quantitative world that actually drives our economy. Right. And so it's exciting to be here today.
So thanks, Jack. That's a really good introduction. And you've been very vocal about AI versus AQ. Can you explain to people who don't know what that is? And also, can you touch upon LLMs versus LQMs and why does that matter right now in the world?
It's a critical question. Right now, most everyone here is using one of the LLMs, ChatGPT, Google, Gemini, Anthropic, all very good LLMs, and people should be using those. And that can help you summarize documents, help you learn a subject, many good applications. But fundamentally, if you want to create a new product in the world, a new medicine, we don't really want to ask a model that was trained on social media and cat pictures to make a new medicine for us, right? We want a model that's trained on biology, on chemistry, on physics. That is quantitative AI. So instead of large language models, Sam, we talk about large quantitative models, LQMs,
right,
versus LLMs. And that's what's so exciting now. When you look at what the industries are doing in biopharma, in chemicals, in energy, in batteries, they're now saying, yes, we can use LLMs for customer service, for marketing, but LQMs will be the core of how we actually generate revenue and profit in the company. So I think this is a very exciting transition moment in AI. 2 years ago, supernova explosion of AI into people's minds. We had talked backstage about your brother-in-law who told you about AI 15 years ago from a pharma company. My cousins tell me the same thing. Jack, you told us about AI 20 plus years ago. Now, finally, it's coming to bear, but it's not just about language and words. It's really about the essence of what drives our economy. That's where LQMs are at.
And this is what you talk about, pristine data, right? So what's going into the LQMs?
That's a critical point. Where does the data come from to train an AI? Well, in the large language model case, we know where the data comes from. It's coming from the internet, from the World Wide Web. Recently, in New York, we had a celebration for my friend Sir Tim Berners-Lee. Tim Berners-Lee is the founder of the web, the creator of the web, and he just has a new book out called This Is For Everyone. I do recommend people check out his book. It's about his experience creating the web. And what Tim essentially did, now we realize, is not just create a useful tool called the web, but create the largest human data set for the large language models. So that's all good for the language models. But now let's talk about the real world, the world of making materials to make buildings stronger and taller, the world of making new batteries to store the energy of our world, the world of replacing plastics. I think all of us would desire to see less toxic plastics in the world. The world to see better food. All this cannot be done with a large language model, but can be done and is already now being done with large quantitative models. So where does the data come from? We can't get it from the web because the web is just words and information, people's speculations. So what we have to do is we either have to use the equations of the world themselves, that's physics, that's engineering, that's chemistry, and we build very large data sets. We're lucky enough, Sam, to have Nvidia as one of our investors, one of our partners as well. And with Nvidia's help, we've been able to create data set after data set. We just released 2 of them in the last few months. One is for biopharma, and one is for the world of materials. One is called SARE, one is called AQCAT 25. And I commend people to check them out. They're free to use non-commercially. And these data sets are the ones that we can use to train language AI models for the real world.
Right. We were speaking backstage, and I felt like I had a masterclass from MIT or something. I'm a lot smarter after meeting you, Jack, for sure. And one of the things for someone like me who's a non-technical person but lived and worked in the tech industry for a long time, one of the things that I love about you, Jack, is that you can explain real-world problem solving that the AQM is doing. Can you just share some of those? So we were talking about the GPS, we were talking about how biotech is going to be transformed and the speed of that. So when people worry about AIs taking our jobs, blah, 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 actually AQ is changing the world in a real way. So can you give us some examples? Because I think the way that you explain it is phenomenal.
Well, thanks, Sam. No, I think you hit a very, very important point there. When we talk about language models, a lot of what people did will be done by language models, and we know that. Recently, Salesforce let go 4,000 people in customer service or reassigned them because the AI was doing customer service, and that's a great application for language models. But when it comes to the kind of innovation we want to see in the world, we know that Alzheimer's is a growing epidemic now. We know as the population ages, we're going to have more need for solutions. 40 years of research on Alzheimer's has given us nothing.
Right.
And when you look at clinical trials, the failure rate in clinical trials is very, very high. And right now it's about 85% of all clinical trials fail. And so what can we do about that? When I was a researcher at NIH at the National Institutes of Health, when I first started my career, I saw all these failures around me. I saw a need for a new kind of computer system that would simulate the body, simulate the human physiology, and understand how we can create a medicine in a better way. And so now we're at the point where compute has caught up, algorithms have caught up. We now know how to make these kinds of models.
Right.
So biopharma, drugs, medicines, that's one of the first things. And I hope we can go beyond medicines, which treat diseases, to wellness and preventative. So that's one big area. When you talked about GPS, I think that's another key area. Here in the Gulf region, it's one of the regions where GPS is jammed the most. So if you have a chance to talk to the pilot of your plane as you're, after you landed, if they come out of the cockpit and you say hello to them, ask them what they experienced when they just landed your plane, either at Dubai or in Abu Dhabi. They will tell you it's very hard to get a GPS signal. as you're flying a plane in the Gulf region.
That's quite scary, by the way.
What's that? It is scary.
Very scary.
It is scary. And that's the same, by the way, in many areas in Asia. It's the same right now because of the Russia-Ukraine conflict.
Right.
It's very difficult to get GPS in many parts of Europe. 41,000 flights, Sam, over the last year have had GPS problems.
Wow.
So this is a big issue. So what is the solution? Well, what we realize is that we can use AI, quantitative AI, LQMs, in a novel way. We can take sensor data of the magnetic field of our Earth, so not GPS from satellites, but fly the way birds fly,
Right.
navigate the way whales do, which is with the magnetic field of our Earth. Now, no human could read those signals. We need an AI that could read those signals, and that's what we created at SandboxAQ, and that's now flying. Airbus just announced recently they took our AI and flew 101 flights over 44,000 kilometers, and it met all the standards of navigation. That was reported in the Wall Street Journal. So
Incredible.
it's starting to happen right now where the vista for AI is opening up well beyond ChatGPT.
Incredible. I'm looking at the clock and we've got, like, it's just not enough time. We could sit here for hours, and we actually did backstage.
And the question is, does Mark Boutiu have a question? We don't know.
I'm going to finish the session, although I've got another 100 questions here. But I think we can talk about scaling, etc., etc. And a lot of people are going to be doing that in other sessions. But because we have you here, I'm going to ask you, if we sit here again in 5 years,
Yeah.
one, what's the most exciting thing that you know is going to be happening for us? And what is going to be the most surprising thing for us?
Well, let me first start with a caution in terms of what I think also may happen that I'm very worried about. I want to share with you, and maybe together we can think of a solution. One of my biggest concerns on the large language model side of AI is the dopamine cycle. I think we all know how dangerous online experience has become in terms of people scrolling endlessly on TikTok
Yeah.
and Instagram.
Yeah.
I myself find myself sometimes, scrolling. Certainly younger people today constantly on TikTok, things
Yeah.
like that. And it is quite addictive. That dopamine hit again and again and again is very, very biologic. I started my career as a neuroscientist, and I can tell you the dopamine effect is very real.
Right.
And even if you wanted to put it down, it's very difficult to do that.
Yeah.
So just saying to yourself, I will stop tomorrow, is really, really hard. And my concern is that right now, when you look at the text-to-video apps right now that are making new video out of AI, they just first started as an interesting, cool feature. I could type something. I could then have a video of a teddy bear running down the streets of New York,
Right.
climbing the walls, okay, things like that. But now, the most recent iterations of the text-to-video are more like social media.
Right.
And so I'm concerned that we're going to turn AI into yet another dopamine hit cycle, and I don't think that's great for human society. So the one thing I would say as a cautionary point is, let's see if we can direct AI to better outcomes than just yet another way to suck time away and turn our brain into dopamine cycles.
Yeah.
On the positive side, Sam, I would hope to sit here 5 years from now and really see concrete results of the kind of AI we just talked about here today.
Yeah.
I don't want to wait 10, 15 years to see progress in Alzheimer's and cancer. One of the cancers we're working on right now with partners, we are not a drug company, we work with medicinal companies and others, is brain cancer, is glioblastoma. That is one of the most deadly of the cancers. Again, 30, 40 years of research by the industry has not yielded anything of great effect. And so I hope in 5 years we can sit here, Sam, and that I can report to you that we do have indeed really good progress in these areas. I hope the same for our physical world as well. And so I think that there's a lot of work to be done. I think, folks, my recommendation to everyone is really to think about broadening your scope in terms of how we think about AI. Yes, it's great to type fun things in and get essays back for your homework as a kid, but there's a much broader application of AI now. And I do think for companies, it is really a case of AI or die, where if you're not really embracing AI, not just in your customer service, not just in marketing, but in the core product development, that to me is the litmus test, Sam.
Yeah.
Can we sit here 5 years from now and look at the Global 1000 companies and say, have the Global 1000 companies gone beyond just marketing and customer service and other areas around? Are they creating the product with AI itself?
Yeah.
And I think that's one of the tests we can apply.
Let's change the world, Jack. I think that's what you're saying. Let's use our intelligence, our technology to actually do real world problems. So I would encourage everyone, I have Jack's book here.
Very subtle title.
So AI or Die. So please do check that out. And if you want to learn more from Jack, watch his YouTube. I'm obsessed now since I knew that I would be doing this. Fireside with you, Jack.
Sam.
I've been watching lots of your YouTubes, and it's really changed the way that I think about AI and quantum as AQ. So thank you for that. And thank you for sharing all of your knowledge. I wish we had longer, but thank you, Jack.
Thank you, Sam. Thank you, everyone.